Welcome back, everybody. This is Town Nerd here. Welcome to episode 2 of the LeetCode Completionist. We're going to be continuing our way through this Challenges for New Users list that was suggested to us when you create a new LeetCode account. If you missed last episode, I recommend you go back and watch it. We did the Roman to integer problem and went surprisingly well first try. So we're going to try to continue that momentum on with the second episode. We're just going to move down the list here. We're going to do this Palindrome Linked List. I'm going to keep it in Kotlin for now. That may change in the future depending on what y'all want to see, but let me know. So let's get into reading this problem. Given the head of a singly linked list, return true if it is a palindrome. Okay, so if you don't know what a linked list is a list of objects with a pointer to the next object. So this first object has its value, and then it's a link or a variable for the next value. So right here it says class list node. It has a value, which is an int, and then a next variable that is another list node. So you can move your way just by going to whatever object.next, and you'll move to the next one in the list. So what this means is we really can only go in one direction in these lists. So example one, you have 1, 2, 2, 1. This is a palindrome. Palindrome meaning if you split it down the middle, it's the exact same on both sides. So 1, 2, 2, 1. Split it down the middle, or flip it, read it backwards. 1, 2, 2, 1. It's the same. This is example 2, 1 and 2. If you read it backwards, it's not the same. 2, 1. So we'd have false. So very, very simple explanation for the problem. Our constraints are number of nodes in the list can be 1 to 10 to the fifth, and the values can be 0 to 9. So only single digit values. This can be very large, and you have to determine if it's a palindrome or not. So let's get started. So right off the bat, I think what we want to do is find the midpoint of whatever list we have. And so if it's an even number, we'll get an exact number. Or I'm sorry, if it's an even number, we'll get an exact value. And that's where we need to go to for the middle. So if it's a size 6, we divide it by 3, and then you want to go 3 nodes in, compare it to the other side, and make sure that it's the reverse. If it's an odd number, that middle number we don't care about. So let's say this is a 5 node list. So we have 1, 2, 3, 2, 1. This is still a palindrome. You don't need to check this number because that's your pivot point, right? So 1, 2, 3, 2, 1. You flip it 1, 2, 3, 2, 1. So if we say get the halfway point in this list, the size is 5. So what we want to do is max of the half. So 5 divided by 2 is actually 2.5, but if you go to like the ceiling of that number, it would round up to 3. And so then 0, wait, no, sorry, we want to do the floor. Max would give us where this value is. We don't care about this value. We want to go to the floor. So 5 divided by 2 and get the floor of that is 2. So we want to go to the second spot and then take everything up to that point and compare it to everything on the other side of the middle point. So just for sake for now, let's get a value for ceil mid, and we'll do ceiling of just give us the head node. Okay, so we don't actually get the full list. I see. We get just the first node. So what we may want to do is build out a list. So while head dot has next, and I've used linked lists in Java, not Kotlin, so it's not has next, it's not a function, it's just while head dot next is not equal to null, because it will be null if there is no next list. So we want while list head dot next is not equal to null, and that won't get us to the last value though. So let's do well head dot next is not equal to null, and this way we can actually get to the last value. No, that's wrong. Uh, that'll get us to the second to last value. Uh, but we still need, yeah, let's do head.next is not equal to null, and we'll have a check at the end um, for if head.next dot next is null, then we'll grab that value too. Let's just run with this and we'll see. So we're going to add this to an array. So let's have val node val array is equal to a list of and integers, and we'll head.next is not equal to null, and then we want a value for current. Value current equals head, while current.next is not equal to null. Or actually, let's do this. Let's do current is a list node equal to null. No, we'll keep this as current equals head, and then maybe we'll have a temp for now. We may not use it, but list node equals null. And then if you're not sure what this question mark means in Kotlin, this is how you say if something can be null or not. So this means that this head could be null. And if null is if you don't ever want an object to be null, leave the question mark out and it will prevent that object from being instantiated as null. If it's a value that you're okay with being null, sometimes you need to have the question mark in the declaration. So while current.next is not equal to null, and actually let's even go, how about this? We'll do while current.value, var val, I guess, okay, current.val is not equal to null. Because it could have a, if it's the last one on the list, it can have a value, but it won't have a next. And that's okay. So we want to take node val array dot add, and I think to use the dot add function, we want a mutable list. Regular list has a dot plus function you can use to add elements to the array, but I've had some issues where that one doesn't work correctly. I always like to use the dot add from the mutable list. There's no real harm or benefit of using one or the other, so this is fine. It's just up to personal choice. So while current.val is not equal to null, we want to add current.val, and then current equals current.next. So what this should do, and let me do at the end of this, print ln of node val array dot toString, and we'll see if we've filled this properly. So let's do run example test cases. And they're all going to fail because we're not actually returning the Boolean. So let's see here. Error type expected. Type expected. Current.val is an int. Or can I reference it like that? I really hate that that's the name. Okay, so we need these. The expression cannot be a selector. Yeah, why is that var val? It's named val. Or is that tildes? Maybe that'll make a difference. If this is a way you can name variables in Kotlin, I haven't seen it, so that's why I'm having a little bit of confusion here. Okay, but val can't be null. Right, okay. Um, oh, because the whole object could be null. So let's do if head, or we can do current. Current is equal to null. Return, we'll just start with return true. Um, I don't know how this problem will handle this. I know technically if the palindrome is empty, then it's the same both ways. Nothing is also nothing backwards. Technically, I don't know if that's how this problem's gonna accept that. Obviously, it's an option for them to pass in nothing. So, well, it says the number of nodes in the list is always range 1. So that's not gonna happen. But we'll have the check and we'll do false then. I really need to take these constraints and put them over here so that way I have them over here. And is there a way to... Can't close it, we can do that. Okay. Um, could do full screen. Let's not. Let's keep this on the side for now. And we may start using full screen in the next episode if y'all would like. I will, however, zoom in a little bit. I don't know if that's hard for y'all to see in the video. So let me just go ahead and do this just in case. So what you can do when it says these non-null asserted is you can just double exclamation mark it at the end of whatever you're checking to be null. That's not what I wanted to click. And then, right, that was a val, we can't reassign it. So we need to change that to var. I'll change val temp to var as well. I'm not sure if we'll need it, but only say right because same thing. Double bang symbol, exclamation mark, whatever you want to call it. This is saying that we know this is not null. Right, and then we're not returning anything down here. Let's just return false every time right now. Okay, so we got a null pointer exception because val was null, which means current was null. So let's do, well, current is not equal to null, and the value is not equal to null. This may still fail. Also, I'll probably need the assertion. Okay, no, that worked. So standard out, we got the list created correctly. So that's good. We'll keep it here for now. All right, I just had to make a little cut right there. Had to take a little break. Sorry about that. But on the YouTube, y'all won't notice. It'll just be a couple of seconds of silence. That's okay. So let me catch back up to where we were. Right, so we've now got everything in a list that we want. So now we need to actually determine if it's a palindrome or not. So let's get this lined up with the rest of the code. I don't think we need this anymore. And let's do two separate cases. Let's do if node val array is dot size modulus 2 is equal to 0. So this means if it's an even number. If this modulus 2 is remainder division, so if this was, let's say, 3, then modulus 2 would leave 1. If it was 4, it's 0 because it's even division. So to show that, we can do println in that equation, just to show how that works. So standard out 0, because we know it's an even numbers 1, 2, 3, 4. So here, what we want to do is, if it's an even number, then we actually want to divide by 2. So I don't think we need this temp here, but we will need a var for midpoint, and we'll initiate that to 0, and then midpoint equals node val array regular division by 2. And this will give us the middle point, or where we've determined we want to stop, and then check the flip side. So this will give us 2. So we want to go to the second element, which is actually index 1, because arrays start with an index of 0. So what we then want to do is -1 to get the actual index in the array. And what we'll change this to mid index, just for clarity. And then let's get a val substring 1 is equal to node val array dot substring from 0 to mid index. And then val substring 2 is equal to, and what we're going to do here is we're actually going to, instead of doing a substring, we'll just go from the last index to the other side. So let's do this. Let's do mid index 2 is equal to this same thing, but not the -1. We actually want to go to index number 2. So we'll make this a, and this is not the most efficient, I know, a list of int, and then node val array, and I want to go from the end dot, let me check the syntax for this. Because as discussed in the previous episode, I don't use for loops like directly. It's more of for in like the dot for each method, which does a for loop. Here, I think it's this. For I in 5 down to 1. So let's do for I in node val array dot size -1. And I don't know how this will work with variables. So let's do this. Surround this in parentheses. Dot dot. Mid index 2. And then I don't think we need to say step 1. But let's see here. For that prints nothing. If you say down 2, okay. Down to mid index 2, is that correct? Down to 1. Yep. So this should be what we want here for I in the last index down to where mid index is. Then substring 2 dot add node val array at I dot tilde val. And then once this is completed, we want to return substring 1 equal to substring 2. And for else, let's just return false for now, because this first test case is even numbers. If we've done this right, and unresolved reference, none of the following candidates applicable. Oh, dot size, of course. It was just trying to divide 2 by an actual list of objects. And that's not gonna work. Unresolved reference. Right. You need to declare this a val. And you know what? We don't need this up here. Because we're only gonna get this once. So we'll initiate it down here. None of the following candidates is applicable because of receiver type mismatch. Oh, right. It's not a string. It's a array. So we want, I think it's dot split, and then just Kotlin sub array. Copy of range, and then start and end. We could map it. Let's do this copy of range and see if that works. Let's change this to array of then. See if that works. Dot plus then. Oh, missing the parentheses to instantiate the empty list. And actually, we'll make this an array of, so that way these types are the same. Dot plus instead of dot add, because we're not in a mutable list. Unresolved reference val. Well, that's it. Or no, we just need that. We're no longer in the node object. We just need what's there at that index. It's greater than -1. So why is that -1? This have to be 0. not the case. Let's cast this as double. Maybe that's the problem. Maybe this array.size is returning a double. No. Okay, what's going on? Let's do node val array.size. Let's see what that's returning. It should return 4 for this first case. Right, and we know that, and do that. Okay, so this is saying size 0. It's this dot plus. Add element to array. And that's array.copy of. Okay, so let's try back to mutable list of. And let's do mutable list type and mutable list type here. Mutable list of type int. Okay, so let's following candidates clickable. So we can't do that function. So Kotlin sublist sublist. Oh, it's literally just sublist. So that is much easier. Sublist, and this may return a regular list, not a mutable list. So we have to cast this to a mutable list. And we can actually remove these here and go back to mutable list. To index negative. So this is still -1. Oh, let's move this back to dot add and dot add. Okay, so we have a size 4. We output false. Now let's print the substrings just to see what we're getting and see if maybe one of our indices is off. We can remove this because that's working now. Substring dot toString. Oh, right. You need to have the concatenate all these strings. Okay, so one of our indices is off. We're not getting if this is the case, then we can just use mid-index, but I don't think that's what we want. This was right, this 1 to 2, but this 1 is not, so we didn't go far enough. Oh, right, it comes up to this value, not, it doesn't grab this value. So in this case, we can just keep the same index. Because this for loop goes to this value, and this sublist gets up to this value. And there we go. So that works for even cases. Now let's do this for odd cases. We want pretty much the same structure, just we still want the midpoint, but we want to do float division. Because we want to get we're going to get a decimal value. And then maybe around all of this dot ceiling. I know I keep looking stuff up, but that's okay because I don't use all of these functions every day. So it's just ceil of whatever's in there. Okay, so we can do keep those parentheses around it, but just ceiling. Right, and do we want ceiling? I think so. I think ceiling is gonna work. Because then we want to use that here, go up to that ceiling. So if it's 5, we'll get 3. Nope, no, we want to do floor and pass that in here. Because if it's 5 objects, divide that by 2 is 2.5. We want the floor, which is 2. So we'll go, we want the second element. So we want to pass in 2 here. Then we'll get elements 0 and 1. Now to come down, we want down to this mid index plus 2. Now running these test cases aren't going to help us here because neither of these are odd. Um, let's see. Selecting an element. This should just be floor. I know I've already looked this up. Floor of a double or a float. Selecting. See how to properly cast elements in Kotlin. Casting element. Casting ints as floats. Oh right, you can just do add an F to the end of it and it will make it a float value. So what's the problem here? Selecting println. In this case, since I was just missing the concatenates, we should just be able to do this. Sorry there, got a notification on my phone I needed to check. What's going on? Am I missing? Oh, right, missing the parentheses here. Unresolved reference floor. That's what it was, right? Just floor? Yeah. What is this floor division? Maybe this is what we want. Unresolved reference floor. Hmm. Floor div is not. That's expected. This ceiling work. Um, Unresolved reference ceiling. Really? Everything else works for Kotlin syntax. I don't know why this isn't. Oh, I think it's Okay. We have to call it like this. So like dot size, dot ceiling, and then what we want to divide it by. Unresolved reference. I don't know why this function doesn't work. Yeah, floor doesn't work. Floor div. Oh, floor div doesn't work. So let's just get this and print it and see what is happening here. Yeah, that's fine. I want to see what was printed. Just comment all of this out. And just, because it's giving us a float. It's giving us the, yeah, return false. So let's add a test case of 1, 2, 3, 2, 1. This should get us into this else statement. Yeah, 2.5, so that's what we expected. Now we want floor. Do var mid index equals floor of mid index. And let's print that. Floor is not, okay. So what we're gonna do is mid index equals mid index minus 0.5. And we know it's gonna be a 0.5 all the time because we're dividing by 2. So then we'll just cast it to an int and call that a day. I don't know why those functions aren't recognized. It's a little frustrating. Infer type is int, but float was expected. Right, because this is already a float, so we need to just cast it here. Infer type is double, but float was expected. Oh my goodness. Or you know what? I think it's the reference here. Maybe that 0.5 is counting as a double. We need it as a float. Yes. Yes. Okay. So, so I think we want +1 here because we got 1, 2, and 1. I don't know why this is inside the array. Maybe it just output weird. Yeah, there we go. Okay. Great. So that worked. Let's get some more test cases in here. Let's get some that aren't palindromes and of different lengths. So let's get that one with 3. Let's get this one even. We'll keep that one in. We know it works. Now let's add 1, 2, 3, 5, 5, 3, and run test cases. Now this is not going to be the most efficient, but that's okay. Why did it not run? Use example test cases, maybe? Oh no, undo that. Oh, just run code, maybe we'll run all those. Yes, ran them all, and we got what we expected. All right, I think we're good to submit this, and we'll see how we did. Awesome, success, first submission. Now, only faster than 23%, but we use less than 82% of others' memory. So obviously this is not the most efficient way to do this, but that's not what we're going for. We're just coming at the problem, first time seeing it, and just walking our way through it, understanding the problem, writing some extra test cases to make sure that our code works. Uh, so thank you for watching the video. That was another successful episode. Let's try and do that again next time. Leave comments down below if there's anything else you'd like to see, or any comments or questions. I'll make sure to answer them as fast as possible. If you like the video, hit the like button so I know. Subscribe so you don't miss the next episode. Thank you for watching.